Okay, we're going to have a look at what happens if we add a number on or take a number off at the end of our graph y equals a sine x, y equals a cos x. We could of course have a b in front of that x as well. It could be a sine bx plus c, and that would include everything. Now this does exactly what you'd expect it to. If we add on a number, it moves it up. If you take away a number, it moves it down. Okay, so if we have a plus 3, it moves the whole graph up 3 spaces. If we have a minus 2, it moves the whole graph minus 2. So the maximum and minimum values of the graph have changed, but the amplitude will stay the same. So that's the height. That's half the distance above your central line. Okay, and to get that amplitude, you add together the maximum and the minimum, and you divide it by 2. Great, let's have a look then. Let's see if we can name these graphs. So first thing you want to decide, is it a sine graph, is it a cosine graph? Looking at this first one here, it's starting up at 2, it's going down to minus 4, then goes back up to 2, so it's a cosine graph. So I know it's going to be the form y equals something cos, or it's just going to be cos x, because there's one of them 360 degrees. Okay, so it goes down to 4, it goes up to 2, so I'm not interested, that's a minus 4, I'm just interested in the distance. So the distance there is 6. If you go from 2 to minus 4, it's 6. Half of that is 3. That means it must be 3 cos x. Now 3 cos x would normally go up to 3, down to minus 3. But this only goes up to 2, and down to minus 4. So we must have taken 1 away. So that has equation y equals 3 cos x minus 1. If we look at the next one, what sometimes helps, especially with these graphs that look a bit funny, is if you draw in a central line, and then you can see your sine graph, and you can see that it is now even. So this is a graph of the form y equals sine, and it's just sine x again, because there's only one of them in 360. It goes up to 7, it goes down to minus 3. So that there is a full distance of 10. 10 divided by 2 gives me 5. So it must be 5 sine x. Now 5 sine x would normally go up to 5, down to minus 5. But this goes up to 7, so I must need to add on 2. Okay, let's try the next one. Right, this is the drawing of the graphs then. Okay. Again, I want you to concentrate more on the namings of the graphs, but sometimes if we can draw them, it does help name them as well, so it's still worth looking at. If I'm looking at 4 sine x plus 2, now that would normally go up to 4, but I'm adding on 2, so my maximum value is 6. It would normally go down to minus 4, but again, I'm adding on 2, so it only goes down to minus 2. So if this is 6 all the way up here, then that's going to be my minus 2 down there. Oh, that was a really bad straight line. Now a sine graph normally starts at 0. 0 plus 2 is 2, so I'm going up to here, and then I'm drawing in a normal sine graph, and it's going to stop up here at 2 again, so that's at the value 2. That would be line there, shouldn't have been there. Just my pen dragged. So that would be 360. If we split it up evenly, 180, 90, 270. And I'll let you see a nicer drawing of it. So 4 sine x add 2. This is it here. So it starts at 2, goes up to 6. Let me just change these settings. See it a bit better. There we go, that's better. Right, so it starts here at 2, goes up to 6, down to minus 2, and back up to 2 at 360 degrees. Okay, you'll notice all your points have been moved along. So your maximum's still at 90, your minimum's still at 270, but it no longer cuts the axes at 180. Instead, it goes through 2 at 180 again. Let's have a look at the next one. We've got minus 2 cos x plus 1. Minus 2 cos x would normally have a maximum of 2. We add on 1, it's now got a maximum of 3. it would normally have a minimum of -2. Add on 1, now has a minimum of -1. So maximum's 3, if we make that there my maximum. Make my minimum -1. It's cost graph, it would normally start at 3, but it's a -2 at the beginning, which means it's upside down. So it's going to start down here, go up, turn, back round, and down. So there's my 360 degrees. It's still going to be at the maximum, 180, but instead of crossing through the axis at 19,270, it's going to meet your central point. So it's going to go through this point here at 90 and 270. Okay, we'll have a look at that one. Go to that graph. Let's have a look at this one. So -2 cos x plus 1, starting down here at -1. It's going up, and you can see really clearly on this graph, because it's all nicely labelled, that it's going through your central point here at 90 at 1, back up to your maximum value still at 180, down to your 1 at 270, and back down to your -1 at 360 degrees. Okay, keep going then. Third one, got 3 sine 2x minus 1. Maximum value would normally be 3. We take 1 away, so we've got maximum value of 2. Minimum value would normally be -3. We take 1 away, so we've got a minimum value of -4. And we'll spot my mistake there. -1. Oh, let's fix it. Thinking of the answer before I've written the question down. Okay, so it's going to go up to 2, down to -4. So it's going to go up here to 2. Let's go down here to -4. It's a sine graph, so it's going to start here at 0, and I want 2 of them in 360. I'm going up, down, round at my -4, back up through here, and do the same again. That's going to be my 360, 180, 90 is going to be when it reaches the central point, so about there, and 270. I'll show you this one. That one. There we go. So starting here at -1, going up to 2, round and down, finishing back here at -1 at 180, which is the period of the graph, and then doing the same again to 360 degrees. Last one, 2 cos 3x plus 1. Do you know what? I'm just going to show you this one rather than me attempting to draw it onto that tiny space. Here we've got 2 cos 3x plus 1. So we've got a maximum value, can only be 2, but you add 1 on, so maximum value of 3. Minimum value of 2 of -2 plus 1 goes to your -1, and you've got 1, 2, 3 of them in 360 degrees. Okay, I'll leave you to practice naming some of these then.